In this module, I'm going to provide you an overview of the water treatment plant. In general, there are three types of water treatment plants, and these differ based on the quality of the source water entering the plant. The first type is the filtration plant. This is a plant that treats mostly surface water. Its goal is to remove mostly color, turbidity, taste and odor, organic matter, and bacteria. We will discuss this plant in terms of its reliance on coagulation and sand filtration. The second type of plant would be a simple disinfection plant. This plant receives groundwater with excellent water quality, or even surface water coming from the headwaters of a watershed that is also very pristine. By the Safe Drinking Water Act, all public water supplies require chlorination. So if the source water does not need to be treated, it will still need to be chlorinated, and this plant is called a simple disinfection plant. The third type of plant is the softening plant. The water that enters the softening plant is excessively hard, which means it has a high concentration of magnesium and calcium. A softening plant relies on softening precipitation reactions, which will be covered in another module, and sand filtration. Because the softening reaction requires elevated pHs, a final step of a softening plant is to adjust the pH to around 7.8 to 9. The overview of a filtration plant, this is something that you should be able to draw in a test setting. Water enters the plant and passes through screens. The purpose of bar screens is to remove large debris. After the bar screens, the water enters the rapid mix basin, which is where coagulation occurs, the flocculation basin, which is where flocculation occurs, the sedimentation basin, which is where sedimentation occurs, and then the sand filter, which is where the filtration occurs, in which the name of the plant gets its name. After sand filtration, the filtered water is disinfected, and there are several different disinfection mechanisms, but in this class we're going to focus on chlorine disinfection. And then it enters the water distribution system. Storage can include water towers or clear wells. For the softening plant, the schematic looks very similar. Water enters the plant. A bar screen is not shown here because it is assumed that this comes from groundwater and would not have large debris in it. But some surface water requires some softening, and if that's the case, you would have bar screens here. The Kansas River plant is a softening plant. And so it is surface water, but it does have a significant hardness that needs to be removed. So water would enter and pass through bar screens or not, depending on the presence of large debris. It would enter the rapid mix basin, and this is where softening chemicals would be added. In a softening plant, it is also possible that coagulation is performed as well. So softening agents may be added here, plus coagulants. The reaction basin is still a flocculation basin. Then you have a sedimentation basin. And a difference in the softening plant is that recarbonation is typically required after sedimentation. This involves bubbling in gaseous CO2. After recarbonation, sand filtration occurs, disinfection, and then pumping to storage in the distribution system. In this flow diagram, the only difference is the chemicals that get added here. In coagulation, you add coagulants. In softening, you add lime or soda ash. And then recarbonation. Otherwise, the flow diagrams between the filtration plant and the softening plant are exactly the same. I'm going to give you one slide to introduce the terminology for each of the steps. Coagulation is defined as a method to alter colloids so that they will be able to flocculate and form larger particles. Coagulation is not flocculation and is not precipitation. Coagulation is defined as charge neutralization. So the general procedure is to add positively charged ions, or cations, to the solution. The cations that you add interact with negatively charged natural organic matter or negatively charged microbials, and in this way you have charge neutralization. We're going to cover this some more in depth in another module. The coagulants you add, the chemicals that you add, must be effective, non-toxic, and insoluble. Softening is defined as the removal of chemicals that make the water hard. The procedure is to add lime and soda ash, and you should know the chemicals that are referred to as lime. So calcium hydroxide is called quicklime. Soda ash is sodium carbonate. When talking to operators in the field, you would never describe calcium hydroxide or sodium carbonate. They are always referred to by the common name lime and soda ash. Lime and soda ash are added and they precipitate out carbonate hardness or non-carbonate hardness. They precipitate out magnesium and calcium, and we will cover that in a second module as well. Flocculation is defined as the aggregation of particles into settleable flocks. The general procedure of flocculation is to gently mix aggregates so that they come into contact with one another and they aggregate. Flocculation is the process by which particles interact. Flocculation will always follow coagulation or softening. Sedimentation is simply the removal of those settleable flocks by gravity. The general procedure is simply to provide a quiescent environment and then to provide a hydraulic overflow velocity that is less than the settling velocity of particles. And we will discuss that in class. Recarbonation is a step that is critical for softening plants, and it's the process by which the pH of the system is lowered, and it also adds some alkalinity back into the water after softening. The general procedure is to dissolve CO2 gas, which adds carbonic acid to the carbonate system and lowers pH. This will also contribute some alkalinity because the carbonic acid will react to form bicarbonate near neutral pHs, which contributes to alkalinity. Filtration is simply the removal of the residual turbidity, and so the goal is typically to get to less than 0.3 normalized turbidity units, or NTUs. The procedure is to pass finished water through a porous bed, which traps particles. And this porous bed is typically sand. It might also be combined with anthracite coal, which is described as a dual bed filter. As the filter fills up with particulates, it routinely has to be backwashed to remove the concentrated particles and return the filter to its starting efficiency. Okay, the last step before water goes to storage and distribution is that the water is disinfected. This is required by the Safe Drinking Water Act. The purpose of disinfection is to inactivate pathogens and other microbials. The procedure is typically to add free chlorine. How much free chlorine to add and how much time to allow for this step is defined in terms of CT. And so the CT rule takes the concentration of the disinfectant, C, and multiplies it by the contact time, T, to provide units of milligrams per liter times minutes. Utilities are required to achieve certain CT values to ensure proper disinfection, and we will cover that more in depth as well. The purpose of this module was to give you an overview of each unit process in a water treatment plant. Through the modules, we will cover coagulation and softening, which are chemical unit processes, and in class we will discuss the physical unit processes and the design calculations that are typically used with them.